advocates and activists would say that even researching this or, moving forward in dialogue in a serious way is detrimental to, the cause of addressing the root cause of climate change. By tweaking that reflectivity by just 1 or 2%, you could offset the warming from greenhouse gases. There's not an island or a bunker or a dirigible or a spacecraft that gives you the life you can have on a healthy earth with strawberries and coffee and medicine and all of the things that you need.
Hello, I'm Bryony Worthington, and this is Cleaning Up. This week, we're looking into the question of what, if anything, can be done to cool the Earth down while we work on transitioning to energy and food systems that are compatible with a safe climate. This is often referred to as geoengineering. As we discussed at the end of episode 168 with Anand Gopal, as climate impacts mount, so too will pressure on politicians to do something to alleviate them. And compared to trying to artificially suck greenhouse gas emissions out of the atmosphere, intervening to cool the Earth down could look like an attractive option, since if it can work, it will likely be faster acting and cheaper to scale. Joining me to explore this topic is Kelly Wanser, Executive Director of Washington-based not-for-profit SilverLining. We most recently met on board the decommissioned aircraft carrier, the USS Hornet, which is moored in the San Francisco Bay. On the deck of this enormous vessel, researchers from Washington University were testing equipment to release and monitor tiny saltwater particles into the atmosphere, plumes of which could help to deflect sunlight and thereby cool the ocean. This project caught the attention of New York Times, amongst others, but as we'll hear, it ran into some obstacles. So I was keen to speak to Kelly about the broader context for the project and to explore some of the challenges her work involves. Please join me in welcoming Kelly Wanser to Cleaning Up. Kelly, it's so good that you could join us on Cleaning Up. I'm really looking forward to this conversation. And I wanted to just start, as we always do, with the question of you introducing yourself, really, and telling us what you do and why.
I'm Kelly Wanser. I'm the executive director of a nonprofit called SilverLining. We're 5.5 years old, and our focus is on near-term climate risk. So we focus our energy on helping the world better figure out what might happen with climate change over the next 30 or 40-year period, and expanding the options that we have to respond to it to make sure that the climate system is safe.
And so just unpacking that a little bit, really, I guess, if people come across you, what they might associate you with is kind of human interventions to try and hold back the worst impacts of climate change, right? So sometimes called geoengineering or a remediation or a repair. What phrase do you use to describe the sort of interventions you're interested in?
Well, we do use the term intervention, partly because we learned that term from scientists who sort of see this in the complexity of the climate system and the fact that you can, intervene like you do with medicine, but you can't control engineer the outcome. There's some uncertainty, so it has a lot of the qualities of medical treatment. So we've gone with that term climate intervention, which came from the National Academy of Sciences report in 2015. And we're interested in that area from a research perspective because of what I learned when I first started looking into climate change 15 years ago, which is that in all of the scenarios for how we manage climate change, even where we're really, really successful, the climate system continues to warm for a period of several decades. So the origin of SilverLining in our work is really about that, that problem, which is the climate system has a lot of latency in it. The greenhouse gas reductions work slowly. So how do we make sure that we're safe in that period of time?
And what was it that got you switched on to climate change initially? Because you have a background in tech, right? If I'm right, do you want to tell us a little bit about your pathway to what got you asking these questions, these difficult questions?
Yeah, so my original background was in the IT technology sector in security and infrastructure. So I was used to looking at complex systems problems, and my original degree was in economics and philosophy. So I was also really interested in risk. And so I started to, read what were then really infrequent, kind of reports of sort of signs of climate change, and thought about the butterfly effect. And I'd started at the very beginning of my career in pharmacoeconomics, in looking at kind of health patterns and things. And so I thought, well, I wonder what the risk really is. And because I was in Silicon Valley, I had access to some senior scientists. And like I had done in my tech career, just kind of gone to the top people and started asking questions. So it was really out of curiosity. And then as I was asking questions and I was getting to know some of the senior scientists in the field, curiosity became concern. And it became concern for this sort of time gap, this few decades where it seemed like our information level was too low, our risk was too high, and our portfolio was empty. So that seemed like an interesting place to start exploring. And so that's what happened. And it was a gradual process over 7 or 8 years before I switched my career into climate change.
So, Kelly, I'm really interested in that parallel with health that you just made. That if the planet is showing a fever, like it's showing some symptoms of distress from all the buildup of impact, you're really interested in what we have in our arsenal that can help alleviate those symptoms, like that overheating, even as we try to get to the root cause of the problem, right? And we try and remove the source of the illness. Is that a fair description of what SilverLining's really honing in on?
That's the right description. So it's both having sufficient diagnostics. So, the other kind of flip side of the coin of the problem is we're not in a very good position to project how the illness is going to go. And so driving, and there are aspects of research that apply across both dimensions, which is getting better at understanding these parts of the system and what they're going to do, and then how you might intervene to keep that stable. So I think the analogy of medicine is great on a number of levels. One is that, in medicine, you think about treatment portfolio, not just one thing. And sometimes in the climate space, people are focused on narrowing kind of the array of what we have to do, and versus saying, well, actually, there's a portfolio of things, and it's likely to change over time. And I think in medicine too, you have like your acute treatment, if the patient's crashing or the patient's in the ICU, and the things you do to stabilize the patient. And that's not necessarily the same as treating the underlying disease or, bringing the patient back to a more holistic place. And so that analogy is how we think about it, which is if for the purposes of preventing different kinds of feedbacks and ultra dangerous conditions, we want to keep the temperature stable at a certain place. And that actually helps us do the other things we need to do.
Right.
The medical analogy is really helpful too, because in medicine, you're looking for what is safe and effective. And you're driving hard with research to determine what is safe and effective. And if it's not safe and effective, you're not going to use it. And so the objective of the research is to determine, do you have safe and effective options for, improving the temperature profile of the climate system, and really driving research at that without predetermining yet, because we don't have a lot of information yet, what the answer to that is.
You say that what is safe, I mean, it has to be seen as relative to the symptoms, right? Because, I mean, for example, right, when you're suffering from cancer, you'll happily put up with radiotherapy or chemotherapy, even though that has some consequences, because it's got a probability that in the long run it's going to be net beneficial. And is that the approach we need to take, rather than a completely do no harm, that there can be no negative impacts? Because that would seem very constraining.
Well, that's a really great point, Bryony. And it's one of the, I think the things that has inhibited research on these climate interventions in particular has been, and the early research was comparing, these interventions to, pre-industrial climate or current climate, instead of, where the climate is going and like the relative conditions that you're trying to improve. And so I do think there's been a trend in the past few years of people have started to study these things more seriously, to say that the goal is to compare what is looking like a really dangerous and dire kind of trajectory for climate change with the risk profile of these things, and then also try to do research that helps you reduce as much as you can the risk of these things, like you would in medicine.
So Kelly, just to stick with this idea now of the medical intervention as a kind of a good little parallel. I guess what if people were thinking about that, they'd say, well, an awful lot of effort goes into trying to make medical trials safe and to run these controlled experiments and double blinds and placebos, etc. And it's a big endeavor. And I guess you can do it multiple times, but when it comes to trying to experiment with planetary scale interventions, how can we replicate that? Because it's if it goes wrong, it could go very wrong, and there's only one planet. So how do we make sure that we address those concerns that we just can't afford to get this wrong?
So that's a really great question, and it's one of the very big challenges. It's a significant question also about the experiment we're doing with greenhouse gases, because we're creating this quite anomalous condition that we don't have an ability to understand very well. So the issue is, like, you're exactly right. Like, we don't have a cohort of patients, and we can't necessarily replicate the same type of model quite in medicine. But there are analogies here where what you're trying to do is generate representation of relevant parts of the system and very localized effects that you could plug into computer models. And the goal is to try to get computer model simulations and other analytical tools as close as possible to being able to represent what would happen. Ultimately, we're going to rely on that. And so we're looking at, like, what in the natural system is like that we can observe, what pollution does, what volcanoes do. And then are there ways that we could make these models really much more closely represent what would happen? And what scientists have said, and two US science agencies have published about this, and one of them is likely to publish more about this in coming months, is that part of that is to do very, very small scale studies, like the plume of an aircraft or the plume of a ship, observe those really closely, and try to refine the models of what happens at that scale, and then use those models to inform the bigger models of what happens at larger scales.
So just to clarify that, so that at the moment we're trying to do a localized studies that can help us get better at answering that question of whether we should do this, right? The proposal on the table at the moment is not, well, we just need to knock down the regulatory barriers and put in some governance and then it's all systems go. We're at a much earlier stage in this, right? That we're still just working out, can it be done? And is it net beneficial to do it?
That's right. I mean, there are certainly people, in that work in our field who think differently. And who draw on the conclusion that we're going to need to use this, and maybe even some theories about what will work and what won't work. Most of the scientists we work with, that would include senior scientists at the UK Met Office and NOAA, would say, there are indications that these things could be relevant, but we don't have the information that we need to know whether we could safely use them effectively.
But we should at least get to the point where we know how to answer that question. Right.
That's right. And so, so these small studies that help you, model these things better may be critical path to that. And so that's a factor in, how much we can know, how quickly.
And we both met, bringing it very locally, we both met on a disused aircraft carrier that's parked in the San Francisco Bay, where there was a small scale experiment being done on the actual production of the salt crystals that will brighten clouds. Can you tell us a bit about what happened to that project? And it was an example of something where certain parts of the problem are being looked at in detail to build up a bigger picture, right?
That's right. And one of the key parts of the problem is, can you generate the size, distribution, and scale of particles that scientists say would produce the optimum effect with the least waste and the least side effects? And so there's an engineering challenge to say, can you generate this kind of particle stream and then can you study how the atmosphere would respond very locally and then model that out. And so this program, which is the research program at the University of Washington, which is one of the top places for this kind of study, they've, I worked with them before starting SilverLining on, an interdisciplinary collaboration to say, could we create the technology to generate this type of particle stream and study this local process on clouds? And in doing that, could we improve the models not only of brightening clouds on purpose, but could that help us improve the models of what pollution is doing, and therefore the climate projections as a whole? And so a first step in that is, can you create the technology to generate the particle stream and then start to measure what happens to those particles as they hit the atmosphere and make a hyper-localized model of that to help people understand it? And so this was what was set up on the USS Hornet, which is a decommissioned aircraft carrier, but it's not disused. It actually operates as a museum. And one of the reasons that the team chose this site was the idea that you could have a facility that other scientists could come to, and students and members of the public, and learn about this science while it was happening. And that the fact that it's a stream of sea salt mist would be a good thing to facilitate that kind of learning and that kind of open exchange of ideas and information. What we learned is that there's a lot of confusion about these things, and especially because there really haven't been any of these studies that have happened successfully. There was one that was shut down in the UK years ago at Oxford. There was one that was shut down in Sweden, and they get a reaction and a opposition and a response before they're able to generate kind of the science and information that would help people kind of understand what they do. So something similar happened in Alameda, where you get a combination of like some people in the local community who get ideas about things being safe or unsafe and what they might do, and opposition, organized opposition that comes in to wherever these things try to happen and mobilizes. And so I think one of the things we and the people in our community are grappling with is like, how can we break the cycle of having these things be something that people are more educated about and aware of and able to process in the right way. And so that's still the case in Alameda, and there's still a hope that we could work there or elsewhere in a way that's open, that people can have access to.
What was the main source of the opposition? Was there worry? Was it on moral grounds, or was it on local air quality grounds, or just lack of public consultation? What was the main cause of concern?
Well, so there was a member of the community who raised questions about the safety of the sea salt emission, and it was reviewed by their environmental consultants, and we had, I think you were there, we had some of the regulating agencies there when we first doing the studies. The issue is that sea salt is not a regulated substance. And in fact, there's not a lot of research on the safety of sea salt because it's sort of ubiquitous. And so when people start raising questions where they want a certain standard of evidence, like you might apply to a mercury emission or something, there's actually less information on sea salt than there is on pollutants. And that actually created a problem. And it created a problem that we didn't expect. And it's even a problem now in trying to work with regulating agencies, because it's a non-toxic substance that hasn't had a profile It doesn't have a lot of literature. So there's that aspect, which then, can exacerbate like misinformation or fear or things like that, where you don't have the science yet to really step through it. And so I think that's a thing where actually having some of these studies happen would be helpful.
Let's talk a little bit about, you've already mentioned a couple of the interventions that are potentially viable, right? The cloud brightening or the solar radiation management, I know are two that you guys have looked at. But do you want to quickly give us a quick potted history of, because there's been some wild and wacky ideas, right? And so
Sure.
how do you sift through these ideas?
So as an organization, we're science-led and we follow the scientific assessments. The first assessment on these topics was actually in the UK by the Royal Society. And they defined a lot of the terms that we know, like geoengineering, solar radiation modification, marine cloud brightening. And they did the first pass walkthrough of, things that people are proposing to try to cool the climate system faster than you can do with emissions reductions, or to bring greenhouse gases out of the atmosphere directly. And so you ended up with these sort of two classes of ideas. One is like, well, can we, actively pull greenhouse gases out of the atmosphere, which is now known as carbon dioxide removal, and different ideas for how to do that mechanically, how to do it with trees, with the ocean, and various things. The other category of thing, which was the answer to the question of, well, could you bring heat energy out of the climate system, and could you do it within, a decade or a few years if you had the capability? And those ideas related to that involves, different ways of reflecting sunlight or pushing, solar energy away from Earth instead of, coming in and getting trapped there. And so those ideas range from, ways of reflecting sunlight out in space, through to ways of reflecting some sunlight out of the atmosphere, to things you would do on land, and like putting, big plastic sheets over ice caps, or, generating bubbles in the ocean to create more white surface, or scattering particles in the Arctic to try to prevent melt and increase Arctic reflection. And even things like painting roofs white or growing crops that are lighter colored to reflect more sunlight. And so those are kind of the three classes: were sort of space, atmosphere, and land. Broadly speaking, where the scientific assessments landed, starting with the UK Royal Society and moving through the National Academy of Sciences in 2015, was that the space-based approaches require a huge amount of scale operating in space. And for the most part, we don't have the technology for that yet. So one idea, for example, is to create kind of a giant filter film at the Lagrange point between the Earth and the sun. And it might be something like 1 billion square meters of film that you would need. And the idea that I heard was, if you could create intelligent self-replicating robots that you would send to an asteroid, they would mine the asteroid and then they would build this thing. And so that, is obviously not a super near term kind of engineering. So I think when people talk about the space-based approaches, like, we're used to being able to try to do ambitious things in space, but the scale of this is really quite something. The land-based approaches or the surface-based approaches have had a lot of appeal to people, because it sounds like, oh, this would be great. We could paint roofs white, grow light-colored crops, and it feels less risky and maybe even more natural to do things on the surface, even if you're scattering silicone beads on the Arctic or putting plastic sheets down. What scientists have said is, the scale required to alter the reflectivity at the surface is large, and the things that you're doing tend to have an impact on the biological and chemical processes that happen between the surface and the atmosphere. So they're actually invasive. And so at scale, doing these invasive things has, potential impacts that are pretty significant. And at the same time, one of the drawbacks of doing things at the surface is you have clouds in between. And so, among other things, the effect is dampened by the fact that you're, lower down and underneath the cloud layer. So where scientists have landed, and you'll see this in, the recent news and publications about these things, is that, one of the primary ways the Earth system itself, kind of maintains this Goldilocks environment that we're in is that sort of, shiny blue dot that you see from space, that reflection of sunlight from the atmosphere itself. And by tweaking that reflectivity by just 1 or 2%, you could offset the warming from greenhouse gases. And so that's really where they've landed in terms of focus, and kind of what you're seeing now in terms of focus for the fast-paced types of things.
And as I understand it, there's 2 tiers even there, right? There's the upper atmosphere, and then there's the lower atmosphere interventions. And none of these are permanent, right? So these are activities you would undertake to temporarily reflect, and then they fall back down to Earth, I guess. Is that a rough characterization?
That's a rough characterization. Right now, there are actually kind of 3 things that people are looking at. So there's the primary effect that I talked about with pollution, which, pollution comes up from the surface and hits the low cloud layer. And it can stay as haze. If it mixes with clouds, it stays in the atmosphere a bit longer. But it's kind of a few days, maximum of a week. And so it's temporary in that way. The effects when you start cooling a large part of the system or the whole system, over time, it changes the behavior of the system. So it's not the case that it's completely transient if you were doing something at scale over time, because you'd have changed the cooling of the ocean and the circulation of things and maybe things that you want to change. But it's not purely transient in quite that way, which I learned from climate scientists. So it's very transient in that, like, if you started doing it and stopped doing it after a week or 2, it would go away. But if you were doing it over the course of years and you'd been cooling the planet this way, there would be effects from stopping. And you would have created effects that are more sustained. In the main candidate for this, which is based on observation of very large volcanoes that have erupted and pushed particles all the way up to the stratosphere, which is one of the outer layers of the atmosphere. In the stratosphere, you have these very high winds and this very rapid circulation. And so it has 2 characteristics. One is the particles stay up there a lot longer. So they'll be entrained up there for over a year, and they'll start to fall out gradually. The second thing is they disperse very quickly around the planet. So you get this much more even distribution and dispersed effect from what's happening. The third category of thing is the upper layer of clouds in the atmosphere, the cirrus cloud layer. And those cirrus clouds act more like an insulation than a reflector. And so if you disperse particles in them, you can increase their insulation, or you can thin the clouds and actually make them less insulating. And one of the things that is an active area right now is looking at how our current commercial aircraft that are currently flying are having some of these positive and negative effects. Right now, there's the thought that commercial aircraft are adding to that insulation effect, and that by changing aspects of the way that they fly, we could reduce their impact that way.
Yeah, because that's one of the puzzles in the various sectors you have to go through to think through how do we eliminate their greenhouse gas contributions. aviation's always been a really complex one, not only because it's physically difficult to replace a fuel-based system, but also you have all these other effects of emitting particulates and water vapor at a particular part of the atmosphere. And then whether that's, as you say, there's been some controversy about whether it's net cooling or net warming. And it feels like now that we've reached this volume of flights where, if you look at a Skyscanner map, we really do cover all, there's a huge concentration now of flights per day, that it kind of does feel like the net effect of all of that, we should try to work it out, right? That should be something we should be able to solve, and not have these error bars, which, as I understand it, are still pretty large around that question of how damaging it is, or how beneficial it could be.
That's a great point, Bryony, because the error bars on the effects on clouds, both the cirrus cloud layer and the low marine cloud layer, the error bars are almost a degree, at least in the low cloud layer, or the cumulative effect. And so the error bars are kind of too big for determining the efficacy of these applications.
We'll be back with more from Kelly Wanser after this short break.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, and Wärtsilä. For more information on the leadership circle and to find out how to become a member, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues, and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.
I want to switch gears slightly and talk about the politics of all of this. And you mentioned that some of these interventions are relatively local, and then there's the global ones. But are there particular countries that are sort of more bullish, that are moving ahead? I'm just imagining, if I was the Australian Prime Minister and I've got a coral reef that's about to pretty much die, but it's a source of huge national pride and tourism, and are there countries that are exploring sort of localized interventions more than others? And I'd love to hear your views on who's leading this.
Well, I mean, I'll start by saying it's still pretty early and nascent everywhere. And that some of the science challenges that we talked about, persist at the global level in terms of the state of climate models, regional models, and global to regional downscaling and things like that. That said, to your point, so Australia, has had a group that's been early in looking, trying to look at marine cloud brightening within those limitations of the science and so forth, because of the state of the barrier reef and the limited number of options for addressing it. And so that's been emerging there. And that was part of the, very substantially funded program in Australia to look at different ways of mitigating what was happening to the reef. The other place where there's, some substantial funding, if not quite yet, a huge amount of output. In Japan, they have a moonshot program, and one of the moonshots is to do with controlling weather and typhoons. And one of the big impacts that they're facing is, what they're sort of sitting duck islands in terms of the escalation of the size of these storms. And the storms are associated with increased heat energy at the ocean surface and the low atmosphere. And so one of the ideas is that if you use something like marine cloud brightening to cool the ocean surface and circulation coming into these areas, that you could weaken the force of storms. That has not been studied very much. And it faces a lot of the sort of gap problems of our ability to represent, cloud and aerosol processes. But in Japan, this is part of what they want to look at in their moonshot program. So the other place that's quite active in this area is the UK. And the ARIA program, which is the UK's relatively new innovation agency, has launched a program to look at this type of climate intervention, and possibly to do some localized studies of especially the low cloud aerosol type of effects. The UK experienced the unusual Atlantic warming, and the UK is also part of the constituency that has to worry about the AMOC current and some of the tipping points.
Expand on the AMOC. This is the marine current, the saline current, right?
That's right. And I should mention in the context of all of this, because you're from the UK and still active in decision making there. The UK is kind of the father of atmospheric science and a lot of the earth sciences in general, going back historically. And so as a country is one of the leading countries in the type of research that you need to look at both climate change and especially atmospheric types of responses. The UK is also one of the few places in the world that maintained work on tipping points, which was taboo until relatively recently. So one of the tipping points is the major current system that drives the circulation of the ocean and the air currents, called the AMOC current. And that circulation is what maintains the climate conditions in Europe and the UK, which would otherwise, for the latitude that you're at, look more like Siberia. And so what's been emerging in research reports recently is that observations are indicating some strange behavior associated with those current systems. It's one of the areas where we have a weakness in our observational coverage. And one of the things that if you ask scientists that are close to it are like, it should be a top priority that we, waive observations of the AMOC current so we can get a sense of like, is it showing indications of a tipping point? And if it changes, if it crosses that threshold of change, then scientists are saying, it's not something that you can reverse. So one of the drivers of looking at these more rapid interventions, like going back to our conversation at the beginning of stabilize the patient, is, are we approaching tipping points? Are we approaching, dangerous conditions for different parts of the system? And we need to kind of arrest the warming and make sure that those kind of changes don't happen.
So the countries that are kind of moving sort of pragmatically forward with some studies, but I mean, it sounds quite piecemeal and there's not a huge amount going on. Are there, on the other side, are there countries who are very resistant to this, even as a concept? And maybe now is the time to pivot to discussing that question of where is the resistance and how, we can talk through some of the downsides, right? We've been relatively exploring it neutrally or positively, but there are lots of people who have concerns, right? That this is something we shouldn't be doing.
Yes, there are lots of people who have those concerns that, this isn't something we should be doing. And also this isn't something we should be researching or necessarily discussing in a serious way. So there's kind of a spectrum of concern, that we would actually do these things and whether there are, negative societal effects from even taking them seriously or researching them in a concerted way. So that's, that has kept them from being researched. And so I would say up until the past 5 or 7 years, some of our work and the work of other people to try to open up research and try to, help people understand that's related to like core climate research on aerosols, that's been helping. But in general, and people like Al Gore, like some quite prominent advocates and activists would say that, and have said, that even researching this or, moving forward in dialogue in a serious way is detrimental to, the cause of addressing the root cause of climate change. And so I have a lot of sympathy with that. And especially with people who've been, been in this sphere since the 80s or the 90s, where, you would say, oh, well, we should just dial down over the course of the next few decades our use of fossil fuels. And of course, we wouldn't let the climate system get to this kind of, very dangerous state. And so studying what happens in that very dangerous state and studying ways to mitigate that very dangerous state doesn't make sense. So I have sympathy for that. And again, it's a bit like if you use the medical analogy, you have an uncle who's pre-diabetic and, like, okay, uncle, here's some medicine to take, go for your walks, dial down the sugar. And you flash forward, 20 years later, and now more extreme treatment is needed. So that we're in that state. But the objections remain, and those communities of opposition are strong, and they're able to activate, very specifically on steps forward in research as a nexus point where if you can stop the research, you're not going to get it downstream as an alternative, and you may not even get a serious dialogue about it because there isn't a lot of evidence to inform that.
I know I've had this conversation when I've been in India, and they have got some evidence, right, of the kind of solar radiation effect that comes from a volcano then having a knock-on effect on their monsoon and their crops and their water provision. So it's not just sort of ideological opposition. It's actually based off some empirical evidence that when these systems get intervened with, there are unintended consequences. And for a country like India with 1 billion people that are all relying on a lot of subsistence farming, that kind of risk then it comes back to our risk profile, right? Is the intervention worse than the cure, or vice versa?
Well, you raise a great point, and it's that point that was one of the motivators for SilverLining, because the very early studies on these kinds of interventions, solar radiation modification or SRM, were using the tools that they had available. So they started with models that turn on and off the sun, and then they went to models of volcanic eruptions. And then, the very first model that our research director supported while he was at the US agency DARPA was looking at the most extreme case for emissions. And so the most extreme case for, putting material into the stratosphere. And so those started to improve the sort of realism of it, but they weren't very realistic. And then they were getting some of these side effect profiles that in more recent years, as we've been able to support more realistic ways of doing things that, would be less bad, then you're not seeing those same findings. And so it's making a strong case for research so that, we can generate evidence about what the realities are versus like these kind of initial quick pass type of studies. So now in SilverLining, one of the first things we did in our research practice was to support more realistic simulation of intervention in the stratosphere, where you would do, controlled simulations. One of the very worst ways to do it is to emulate a volcano. It's like think of medicine, like one big blast of chemo all at once. It's not what you would do. So when they, when they did these studies of these different control models for doing it, of course, the side effect profiles came down, including the monsoon. And I think one of the goals of the people in the SRM community and in various groups, again, based in the UK and working with the Global South, is to say, can we improve the tools that we have to do high quality simulations that are realistic, and then give people access and tools to be able to look at how this will affect their region.
We haven't mentioned one major country that is very up to speed on climate science, and that's China. Have you got any sense of whether China is interested in this, is pursuing it? But what do we know about what's going on there?
We've had a few touch points. They actually had a British researcher who ran a program in China, one of the Chinese universities, a modeling of mostly stratospheric interventions, and we've had some touch points with senior researchers in China who were looking more on the carbon dioxide removal and marine carbon dioxide removal side of things, because they have such a big vested interest in the ocean and the health of the ocean, in their aquaculture. So they're really interesting in that, they have quite sophisticated science capabilities. They built a dedicated climate computer, or sorry, supercomputing system, which we don't have in the United States. We don't have a supercomputing system that's dedicated only to climate research. I don't think you don't have one in the UK either. And so they have that, but they're using the US and other climate models, so they don't have their own native climate model development. So there are aspects of the problem that aren't as native to them, but they are able to spin up things quickly.
Yeah, well, that's absolutely. Yeah.
And they are looking at problems. If you look at their work and we haven't touched on this when you asked about localized things, kind of the flip side of the coin, which is cloud seeding and rainfall enhancement, which is going on.
Which already happens, right, for crops and water.
Yeah, it's
and that's not governed by any. Is it governed by an international treaty of any kind?
It's not. There was a treaty that happened after the Vietnam War called the Enmon Treaty, which was about not trying to weaponize weather engagement. But it doesn't speak to, people trying to influence weather on their own behalf. And I think what's happened is that cloud seeding started in a highly localized way. If you think about ski resorts and snowmaking, right? And then, a lot of the cloud seeding in the US is focused on snowpack. And it starts out in this localized way, but as, water conditions get more impacted and people are trying to do more, these things are growing. And two of the biggest places in the world for big scale efforts are China and the UAE, the Middle East. And as these things grow, then they start to look like a bit what I was talking about, where they're starting to affect kind of weather patterns and the long distance telekinetic effects on other places and their weather. And we have a lot of uncertainty in all of that stuff. So the origins of cloud seeding, like a lot of that activity in the United States, for example, or the UK, would be governed by, in the US by the EPA and by, what gets emitted into the atmosphere and what's safe to breathe and so on. The piece that isn't governed is the sort of, local to regional to, trans-regional effects on other places.
This all feels like to me that, well, so one thing I've been musing about is we've had 36 COPs under the UNFCCC, and we have the Paris Agreement, which has largely taken away the need to negotiate anymore, right? Because it's mostly now nationally determined contributions. So what is the thing that the UNFCCC is really working on? Like where are the negotiations going next? And it feels like at some point there needs to be a big work stream kicked off underneath that auspice, which is to sort out all of these questions of observational data, risk assessments, monitoring, like regular reporting back, like not waiting for 5 years for an IPCC summary report, but actually on an annual basis, having a clearinghouse for all this whole topic. It feels like it's such a massive topic. I mean, we've just touched the sides, and there's so many other things we could talk about. But where is this happening in an organized way? Is there an annual conference everyone goes to in your field, or is it really still just not being pulled together?
Well, I would say, first thing I would say is there's a distinction between weather modification and climate intervention. So right now, those are different communities. And they overlap a bit in the sort of cloud aerosol world, but mostly they're different. And there's a bit more in the system around weather modification, at least in the WMO. However, and I think the linkages between weather modification and climate intervention and how these things come together, like that's still emerging. Like I think that's just like for the first year at the American Geophysical Union conference, they're having sessions together, and so I think that again, because the weather modification used to be quite contained, it is now growing to something more impactful. Climate intervention used to be quite ultra marginalized and is now growing into something.
It's not an easy problem, Kelly. How do you keep yourself going? Because you've taken on a mother of all problems, really. It's there's data gaps. It's very disparate. There's a whole host of complex problems to work through on a research side. There's the political side. There's the public acceptability side. I mean, what gets you out of bed in the morning feeling positive that you can have an impact on all of this?
Well, I think some of it is, the people that we have the good fortune to collaborate and work with, and the fact that we've been able to make progress. And so, I'll give you a couple of examples. One is, when we started SilverLining, we started with the U.S. Congress and went on the Hill and, started the conversation about this, this problem of pollution aerosols, kind of the near term, that we don't know what kind of risk we're facing. Showed them pictures of like the tracks of ships from space, and then talked about the fact that people are starting to think about these active interventions that involve dispersing aerosols, and that right now we lack the information base to know how to make a policy response. We literally wouldn't know, if somebody starts putting particles in the stratosphere, whether to help them, whether to shoot them down, what the impacts would be. And that was really compelling to everyone across both sides of the aisle. And so so we got some inspiration from the fact that like there is a pathway for reasonable thinking and for different kinds of people to work together on something like this. As we talked about the observational gaps, one of the observational gaps that we have is the stratosphere. And the stratosphere is a place where if somebody goes to do these kinds of things quickly, that's kind of the target of choice. And we don't have good measurement capabilities for what's in the stratosphere. We have one satellite that's specially configured to look at the stratosphere at a shallow angle like you need, with special instruments like you need. And it's scheduled to go offline early next year. And there's no replacement for it anywhere in the world. And one of the first things we did, supported by Congress, was to help NOAA work with NASA to start doing sampling of the stratosphere, to fly aircraft there and take samples, which they hadn't done since the 90s. And there are currently 4 aircraft in the world that are available for research that can fly in the stratosphere, which has conditions like halfway to space. They're all owned by NASA, and they're all old. And so we got support from Congress to start doing these sampling flights, and now there's enough money to do one every other year. So they can go to one spot in the stratosphere every other year. And so we're like, well, it's a start. So when they did that, they actually found that the stratosphere had changed since the 90s, and they found pollution that wasn't there. And there was pollution from wildfires, which are getting to be big enough to kick things up to the stratosphere. But there's pollution from space traffic, and we're seeing pollution from rockets in the stratosphere. And as that traffic grows, we could start to see, the same kind of profile that we see in the lower atmosphere, where maybe that's helping to cool the planet, but maybe it's hurting the ozone layer and having other side effects. So it's things like that that are quite inspiring and exciting, where you feel like, you can help really smart, innovative people kind of move the needle on progress. And then you see policymakers in both the US and the UN who think about these things in really constructive ways.
It does strike me, though, that that there needs to be a very clear ask made of all of these bazillionaires who are heading into space with their, huge wealth now, that they are investing in this as a almost like as a co-investment. I'm just thinking you couldn't have got the automobile car without roads, right? Henry Ford would not have sold his cars without there being road infrastructure. If you're off sending your rockets into Mars or wherever, that you should be required to invest in the infrastructure we need to keep our stratosphere or our upper atmosphere sort of monitored and safe, right? And these are the people with the money, right? And as you said, philanthropy has stepped into this space to compensate. So maybe there's a big ask here that you need to formulate of those handful of people who are off developing these business models to make sure that we look after our spaceship Earth. This is ground control, and it's got to stay intact and safe, right?
That's a great point. And in the United States, the ground zero for that is NASA. And right now, the circumstance is the opposite. Like the Earth system budgets at NASA are getting cut, and the space budgets are, 10 times bigger, maybe more. And so, so we need, it's helpful. And we've had, high net worth individuals from various arenas that have helped fund this catalyst work. But we also need them to help, on the governmental side to say, we've got to have this public support for these public goods. We do need spaceship Earth. It's not going to be good to be trying to go to Mars and not have a great planet to come back to. So
I know. I have a friend who had a poster years ago, which was essentially an advertising Earth to someone living on Mars. And as soon as you see it from that perspective, you'd be like, I want to go there. I don't want to be on this horrible planet. I want to be over there. This looks like paradise. So
it's paradise relative to anything else. And I think, I think people coming to the realization that there aren't escape hatches for anyone. There's not an island or a bunker or a dirigible or a spacecraft, that gives you the life you can have on a healthy Earth with strawberries and coffee and medicine and all of the things that you need.
This is a beautiful point to end on, because I think it leaves us with the mission very clear as to what we need to do. And you've been super helpful, Kelly, in terms of helping us unpack all the complexities. Is there anything you want to leave the audience with that we haven't covered that you think we need to just leave us with a parting thought?
Well, I think sometimes people raise the idea with regards to these climate interventions, as you kind of touched on, that, there's not a way that the world can make decisions about them. And they're inherently inequitable. And that alone may mean that, it's not a good thing to work on. What we've seen is quite the opposite. So we dug in especially to look at the Montreal Protocol, which has helped protect the ozone layer, and the mechanics of how that works and how it continues to work every year, even when they expand it to do other things. And so there's a lot of hope in our corner that there are also good ways that the world can work together on this problem and navigating this. And based on the evidence that we're seeing, that it's much more the case that we're all in it together. It is much less zero-sum looking than, it first appeared, because it really looks like in a warming climate, all of us suffer pretty badly, ultimately, even if it's in relative terms. And in a place where we're looking at solutions that help bring down the pressure, it's much more of a shared kind of outcome picture, so that part is hopeful. So, I want people to take away that driving science and evidence is what's going to help us, work together on these things, make reasonable decisions about them and help people, participate in a way that's fair and equitable and just. So, supporting that, there's a lot of hope that we navigate through this. And, ultimately, failure is not an option.
Absolutely agree with that. Well, look, Kelly, it's been a real pleasure, and I know there are going to be moments when we make progress, and there'll be step backs, but I'm just thank you for your time, for spending this time with us. Thank you for doing what you're doing, and thank you for talking us through that in such a thoughtful way. It feels to me the last time I really thought about this seriously was many years ago, and even this conversation, I've seen how things are moving, despite the lack of resources, despite the fact this is often a forgotten and a taboo topic. We are getting more sophisticated in our understanding, and it's a lot of that, I think, is down to you and your network. So thank you, and look forward to seeing you in person before too long.
Thank you, Bryony. It was a pleasure to talk with you. Appreciate your questions, and I'll look forward to seeing the podcast.
So that was Kelly Wanser, Executive Director of SilverLining. We'll put links in the show notes to the resources we mentioned during our conversation. And as always, my thanks go to our producer, Oscar Boyd, our researchers, Jeannie Harrison and Alex McInerney, our video editor, Jamie Oliver, and the growing list of people working behind the scenes. Please make sure you join us same time next week for another episode of Cleaning Up.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, and Wärtsilä. For more information on the Leadership Circle and to find out how to become a member, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.